Hello, dear students. Hope you are doing well. This is our 7th week, and in this week, we will do our 6th experiment. Let's begin. Experiment 6. In this experiment, we will activate even or odd LEDs sequentially and deactivate them alternatively. The required components are open source microcontroller Arduino UNO, which is similar to Arduino Nano and Arduino Leonardo, and LED and resistor, and lastly the ground terminal. Here we present the working procedure of our experiment. First we will draw the circuit and take Arduino UNO, where the word UNO means one in Italian language, and it was chosen to mark the initial release of Arduino software. If we worked with the Arduino UNO hardware in lab, we would need to connect the power supply, as it can be powered by the USB cable or by an external 9-volt battery, though it accepts voltages between 7 and 20 volts. Then we take resistors, LEDs and ground terminal, and then connect all of those using wires. Then we will write code for turning on the odd LEDs and then turning on and off the odd and even LEDs sequentially, and turning off them alternatively. And then we will link the code with the circuit. After that, simulating the output will appear. This is our circuit diagram. First we will draw the circuit in Proteus software. For doing that, at first place an Arduino UNO, then take 300 ohm resistors, then connect 6 LEDs with the resistors. I have taken all blue color LEDs. Then connect each LED with a common ground terminal. You can use separate ground terminals. Now the circuit design is done. The UNO communicates with the original SKT500 protocol for communication. I have used here pin number 1, 2, 3, 4, 5 and 6 for the LEDs. We must remember the pin numbers, as we need to give the pin numbers in the code. Now it's time to write the logical codes in Arduino software. We need a variable for storing the pin numbers. Here I have declared a variable named I. It will get the pin numbers from the for loop. In the void setup part, the first for loop runs for the values from 1 to 6. If the value of I is odd, then which is checked in the if part of the code, then the LED will turn on by getting high voltage, and there is a delay of 600 milliseconds after each turning on. So the loop will turn first, third and fifth LEDs on sequentially. Then the second loop runs from 6 to 1. If the variable I gets odd value, then the digital write function will send low voltage to the LEDs. So the LEDs are now turned on. They will turn off in a reverse manner. After that, the third loop runs for the values from 1 to 6. If the value of I is even, then the LED will turn on by getting high voltage, and there is a delay of 600 milliseconds after each turning on. So this loop will turn on second, fourth and sixth LED sequentially. Then the fourth loop runs from 6 to 1. If the variable I gets even value, then the digital write function will send low voltage to the even LEDs. So the even turned on LEDs will turn off from last to first. This screenshot shows the .acx file location. After compiling the code, we will copy the location and paste in the program file box of the Arduino Uno. Now it's time to come to the Protea software to simulate the circuit. This left-sided image shows that the first one number pin connected LED is turned on. Then the next odd LEDs, which is third and fifth, will turn on sequentially with a delay of 600 milliseconds after each turning on. And in the alternative sequence, they will turn off. Here we see the turning on and off sequence of even LEDs. First, 2 number pin connected LED turns on, then 4 and 6 number pin connected LEDs turn on. Then they turn off in a reverse sequence. This is our desired output. Hope you understand the experiment. That's all for this week. Thank you everyone.